So this session I will be discussing equivalence class, which is a very important topic not only for board, for your entrance examinations also. But the concept of equivalence class has linked with higher algebra. Here we will learn because of a relation included in our syllabus. Relation, reflexive, symmetric, transitive, you have learned. And you know what is equivalence relation, isn't it? Equivalence relation R on A means what? Implies that it will be number one, reflexive, then symmetric, and number three, transitive. Okay? Now, if we define an equivalence relation on the set of all integers as follows, that are equal to say xy, x comma y belongs to z. Z means set of integers, and wait a minute, this condition I forgot to write. Xy such that x minus y is divisible by say 3. Okay? And what about x comma y? That x and y belongs to z. Okay? xy belongs to z. Then we can prove that this relation is reflexive, symmetric, and transitive. We have done in the first session with an example x minus y divisible by 4. Here x minus y is divisible by 3. So there is no problem of proving that this relation is an equivalence relation. Because it is reflexive, symmetric, and transitive. That part I am not going to prove. Instead, I am going to discuss some extra point on it. Once this one proved an equivalence relation, you consider partitions on this set. A new term for you. Partitions of Z. I can find a link here. You have seen that in probability, mutually exclusive and exhaustive events. If you have done in class 11 probability, it's fine. Out of these three sets, there is no point common. I mean, if you go by their intersection, what do you observe? It's a null set. Pairwise. This is P2, not P3. P1 intersection P2 is a null set. P2 intersection P0 is also a null set. Okay? So these three we have seen as mutually exclusive and exhaustive events. Here, I am going to state in terms of elements of this set. Suppose I am defining three sets here this manner. P0 equal to 0. You understand my aim? You just write, and this is minus 3, minus 6, minus 9. You will see that nothing new over there. These all are divisible by 3. Yes, I have done that already. But can I take this manner also? Keeping 1 at the center, 4, 7, 11, 14 like this, minus 2, minus 5 like this, or P2, 2, 5, 8, 11, and this one, minus 1, minus 4, like this. Okay? What is the relation among these three sets? Have I found this kind of relation over there? P0 intersection P1 null set? Yes. P1 intersection P2 null set. P0 intersection P2 null set. And one thing is clear here, in case of mutually exclusive and exhaustive event, we get one extra condition. P0 union P2 union P2 is equal to the whole sample space or whole set. Here, if I tell you to make a very simple observation, that condition is obeyed. P0 intersection P1, P0 intersection P3, P2, P2 intersection P1 are all null sets, and P0 union P1 is the whole set of integers. Agree or not? Their union is the whole set of integers, but intersection going to be null set. Now, if we consider this relation, what I have stated here, x minus y divisible by 3, xy belongs to z. So, we are making this observation. You write observation. Number 1, their intersection, pairwise intersection, if you take, they are all null set. Number 2, their union is the whole set of integers. And number 3, elements of one set are related to each other. Why? The relation is what? Under this relation only. The difference divisible by 3. You take any two elements from here, find the difference. 12 minus 0 divisible. 12 minus 6, 18 divisible by 3. You take any two elements from here, 14, 1, 4, 7, 11, 14, minus 2, minus 5, minus 8. Just a minute. Just a minute. Probably I have taken wrong elements here. 1, 4, 7. This I have taken wrong. That's why this will be 10 and 13. You take any two elements from here, they are related. Means what? Their difference will be divisible by 3. You take any two elements from here, their difference also divisible by 3. That's why I'm telling elements of one set are related to each other. But no element of one set is related to any element of the other set. Agree or not? Elements of one set are related to each other, but no element of one set related to any element of the other set. Because if you take 7 from here and 5, there is no relation. That difference is not divisible by 3. Now you can say that these 3 are partitions. There is no element common, and their union is the whole set of integers. These partitions have another name. These are also called equivalence classes. P0, P1, P2, these are equivalence classes. What P0 stands for? This is equivalence class containing what? P0. Equivalence class containing 0. You can write this also. See, really 0 is there. This is equivalence class containing 0. 0 is there. This one. P1 is what? The equivalence class containing equivalence class containing 1. You write 1 inside bracket or 1 bar. Similarly, this one 0 1. P2 is what? Containing 2. You write this or this. Okay? So these 3 equivalence classes are there. 0 bar, 1 bar, 2 bar. Contain 0, 1 and 2. They are least elements, magnitude wise. No, not that, because I have to represent in terms of one element of the set. If you say that, why? I cannot write modulo, this thing equal to, anyone can write this thing equal to 6, equivalence class containing 6. Meaning of this is that 0 we have written, it means equivalence class containing 0. Its elements are obvious under that condition. Here elements are obvious under that condition. They are different divisible by 3. So this is the concept of equivalence class. If you consider this relation R equal to, you try to construct before I do it. R I am writing xy such that x minus y is divisible by 4 and xy belongs to z. Can you write equivalence class here? X minus y is divisible by 4 on the set of integers. So how many equivalence classes will be there? 4. P0, P1, P2, P3. This you can write 0 or 0 bar. This one you can write 1 or 1 bar. 2 or 2 bar. 3 or 3 bar. Okay? You can try the same manner. They can ask you prove that this is equivalence relation and find. Question may arise this manner. Find the equivalence class containing 17. How do you answer that? Concept I told you already, that we can express one equivalence class in terms of any number of the set. That's why 0 replaced by 6 in the element over there. Okay? And 2 replaced by what? 8 or 11 or 14 or 5, whatever you can. So 17 will belong to which class? That you need to state. Very easy to find. Just find the difference divisible by 4. In which case? 17 minus 0, no. 17 minus 1, yes. 17 minus 2, no. 17 minus 3, why no? Because that difference not divisible by 4. So, answer going to be 17, you write this manner, is equal to 1. Understood? This is the concept of equivalence class. An equivalence class containing any element can be determined this way. Okay? Now, on equivalence class, question may arise this manner. That came in board exam. I am going to discuss with you. Just a minute. This I hope you have understood. This question came in board exam. I am writing the sum. Prove that the relation R on n cross n. Complication starts. Relation not only in one set, relation going to be on n cross n. N is a set of natural number defined by what? A, B, R, C, D implies and implied by A plus D equal to B plus C. For all A, B, C, D belongs to n cross n. Okay? The relation. What you are going to prove? Prove that R is an equivalence relation. Also find the equivalence class containing what? 2, 3 and 1. Very good question. Came in CBSE board exam long back. 2010. This question came. Proving equivalence relation is a challenge. You haven't seen this kind of stuff. And then you have to find the class containing 2, 3 and 1, 3. Think, then I'll help. Think first how to prove. I'll give you 1 minute time. Doing. So proving this one is challenging problem. This AB related to CD if A plus D equal to B plus C. How do we incorporate here? Here the main problem is elements are not ABC, it is AB, the order pair. Elements are CD because you are defining on n cross n. So let me try for you. R is reflexive. Same concept. Only element will be replaced by ordered pair. Here elements are ordered pairs only. A plus B always equal to B plus. Agree or not? This you agree or not? See the position here. A plus D should be B plus. A plus D should be B plus. As is always true, therefore AB related to B. Because first plus fourth, okay, wait a minute. A plus D will be B plus C. Is it over there? A plus B, if you say that AB related to AB, AB related to AB, not B. AB related to AB. Why? Because A plus B is B plus. That's why. Condition is that only. First here and second here, their sum equal to second here plus third here. Okay? So that is obeyed. This implies R is reflexive. R is symmetric. How do you prove this? ABRCD means CDRAB. ABRCD means what? A plus D equal to B plus C. CDRAB is what? What's the condition? C plus B equal to D plus C. That is, just reverse. So this 1 and 2 will tell you the same fact. From 1 and 2, implies so R is symmetric. Okay? Clear? Understood? R is symmetric. R transitive value proof. Let AB RCD and C, D are E, F. What does this mean? What does this mean? Understood? And what you are going to prove? You are going to show that AB is related to EF. Okay? So you have to bring A, B, E, F in the scenario. How? Just adding 1 and 2. Then what do you get? This implies A plus F. What's the relation? Am I getting that? First plus fourth, second plus third. You getting that? Yes. Therefore, AB related to EF. Hence, R is transitive. Okay? So you have proved that it is all reflexive, symmetric, and transitive. So it is an equivalence relation. When there is equivalence relation, there is a chance of getting equivalence class over there. We have seen that A minus B is divisible by C, A minus B is divisible by 4. We can define. So here also we can define. And what kind of elements can be related? Elements may be 3, 4, maybe 2, 3, maybe 1, 3 like that. They are asking to find the class containing 2, 3 and 1. Both are there. So how do you start? You have to get the values of, 2, 3 contains what kind of elements that you will find. So you will start this manner. Let AB equal to 2, 3. Did you understand? This logic I have showed you earlier. Okay? This logic I have showed you earlier, and here it is going to be in cross n. All are natural numbers. So I am going to find the equivalence class containing 2, 3 first. Let this is equal to 2, 3. What's the condition? First and second element here, second plus first. This implies A minus B equal to 2 minus 3 or B minus A equal to 1. Now B minus A equal to 1 will be obeyed by what? Is there only one element? No, many elements. Here to B minus A 1 satisfied because 3 minus 2 1. Tell me one more element, 3, 4. Maybe 4, 5. Like that. All those you need to write here. That you write. Therefore, 2, 3 will be take all the elements in such a way that second minus first is becoming 1. So it may be natural number, no negative number you can take. 1, 2, then 2, 3 already there. And write again, no problem. Then 3, 4. 4, 5. Dot, dot, dot. Okay? 2, 3 is this. Now I hope you'll be able to get it for 1, 3. How? Again I am showing you how to find the equivalence class containing 1, 3. Again you start the same manner. Let x, y equal to 1, 3. Okay? Therefore, x plus 3, y plus 1, y minus x equal to 2, elements are of this form. You tell them y minus x equal to 2. What are the elements? This will contain 1, 3, 3, 5, 5, 7, 7, 9 continues this manner. Is it or not? So that year it was the fifth sum, I remember. Okay. In 2010, 2013, similar question came. 2016, similar question came. In between also. So many sets they made. One of those things will find this kind of problem. Okay. Thank you. Hope you have understood.